What up? I'm the math teacher Goat, and today in fourth grade Mathland, we're talking about finding equivalent fractions. This is a big one. Make sure you have pencil and paper because I'm going to do some problems and I'm going to ask you to do some problems. Also, like and subscribe because you love me. All right, let's get right into it. Use the models to complete the equivalent fraction. Well, it looks to me that 2 over 4, in other words, I cut a pizza into 4 total slices. I eat 2 of them, gives me 2 over 4. That is, like if I blur my eyes and pretend that I'm colorblind, these are the same looking picture. This covers up the same exact space. So this is 2 slices and I'm eating 1 of these. So 1 over 2 is the same as 2 over 4. Interesting. You know what I noticed? If I multiply 1 times 2, I get 2. And if I also multiply 2 times 2, I get 4. So it seems like if I multiply both of these numbers by 2, I get the same exact fraction. Wonder if that means anything. I don't know. I guess we'll just have to find out. Use the models to complete the equivalent fraction. Well, again, it looks like I have 1, 2, 3, 4, 5, 6, 7, 8 blocks here. 2 of them are filled in. That's 2 over 8. But if I only focus on maybe just like, the columns part, like if I just focus on this part, I know it's not the same exact size, but you get the idea. And if I fill in that first column, that is me taking something that is 4 pieces and coloring in 1 of them, and I still get the same amount. Like if that is a cake, and if I cut this big cake into 4 slices and eat that whole entire side, or if I were just to cut it into 8 slices and still eat that whole entire side, I still get the same exact stuff. So 2 over 8 and 1 over 4 is the same thing. Very interesting. If I multiply 1 times 2, I get 2, and if I multiply 4 times 2, I get 8. So if I multiply these numbers by 2, I end up with the same exact fraction, just different numbers. Interesting. I wonder if that's going to mean anything. I don't know. Let's do this again. I'm going to cut this pizza into 6 slices, and I'm going to color in 2 of them. But if I were only to cut it in 3 slices, like this, and color in that really big slice, it covers the same exact space. So 1 of these 3 slices is the same as 2 of those 6 slices. Very interesting. If I were to multiply 1 by 2, I'd get 2. And if I were to multiply 3 by 2, I'd get 6. And like if I multiply both of these guys by the same exact number, and that number just happens to be 2, I get a different looking fraction that means the same thing. Very interesting. I don't know. No, I don't know. You try it. You pause the screen. Come back, see if you got it right. All right, so we are taking this pizza and we're ripping it into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 slices. And 1, 2, 3, 4, 5, 6 of them are shaded out of a total of 12, so 6 out of 12 would represent that guy. If I were to draw another circle, cut it in half, and shade in just the one side, I have 1, 2 slices, and only 1 of them shaded, so 1 out of 2. So 6 out of 12 and 1 out of 2 are the same thing. Interesting. If I were to multiply 1 times 6, I get 6, and if I were to multiply 2 by 6, I get 12. So if I were to multiply 1 over 2 by the same number, and that number is 6, I get the same exact fraction, just with different numbers. That's so interesting. It's like I'm trying to plant seeds in your brain of what's about to happen next. That's exactly what I'm doing. Now, this is my cake again. I'm cutting it into 6 parts, and I'm going to eat 4 of those slices. Okay? But now someone's like, no. You take that cake, sir. You take that cake and you cut it into only 2 parts, but shade the same exact space. All right, well, I'll shade you right here. And I only care about 1 out of 2 of those slices. So 4 out of 8 and 1 out of 2 are the same exact thing. Interesting. If I were to multiply 1 by 4, I'd get 4. And if I were to multiply 2 by 4, I'd get 8. So if I were to multiply 1 over 2 by 4 and 4, I get 4 over 8, which happens to be the same exact fraction with different numbers. Very interesting. Very interesting. So now, the last 5 times that I did that, let's put that practice into place. I want to turn this fraction into that fraction and have it mean the same thing. So this is what I'm going to do. I notice that 4 and 12 are lined up in the denominator, right? I'm going to think to myself, well, math teacher fella kept saying, oh, if I just multiply the numerator and the denominator by the same exact number, I'm going to get a different fraction with the same exact answer thing. I don't know what I said there. I said it wrong, but you got the idea. If I were to multiply these two by the same exact number, right, I'll get something that's equal, but I have to be specific here. So 4 times what is 12? 4 times 3 is 12. So let's multiply the top and the bottom by 3 over 3 because 4 times 3 is 12. 3 times 3 is 9. So I'll rewrite this out. 3 over 4 is the same as 9 over 12 because 3 times 3 is 9 and 4 times 3 is 12. And I'm multiplying both of these by 3. So it's kind of like if I were to go back to that pizza problem with the 12 slices, but if I were to show off that it only had 4 slices, 4 slices, 3/4 or 3/4 of a pizza is the same as 9/12 of a pizza. All this pizza talk is making me hungry. Let's do it again. Find the question mark that makes these equivalent fractions. I want these to be the same exact thing. So I have to multiply u and u by the same exact number. Well, what number? 8 times what is 32? 8 times 4 is 32. So I'm going to multiply the top and the bottom by 4. 7 times 4 is 28. So the fraction that I end up with is 7 over 8 equals 28 over 32, and those are the same exact fractions. Okay, they look different, but they're the same exact fractions. Let's do it again. 9 over 10 is the same as what over 50? Well, I have to multiply the top and the bottom by the number that turns 10 into 50. 10 times what is 50? 10 times 5 is 50. 9 times 5 is 45. So 9 out of 10 is the same as 45 out of 50. See, not so bad. So you try it. Find the question mark that makes these equivalent fractions. Do the same exact thing that I did the last 3 times. See if you can come up with the answer. Pause the screen. Come back and check your work. All right. So 2 over 3 has got to be something over 12. I have to multiply the top and the bottom by the number that turns 3 into 12. 3 times what is 12? 3 times 4 is 12, so I'm going to multiply the top and the bottom by 4. 2 times 4 is 8, so 2 over 3 is the same as 8 over 12. 5 over 9 equals what over 27? Well, I have to figure out what number that I multiply to the top and the bottom, or specifically what number do I multiply to 9 that gives me 27? Well, 9 times 3 is 27, so we're going to do 5 times 3, which is 15. So 5 out of 9 is the same as 15 over 27. Try it again. Pause the screen, write these out, unpause it when you're ready, check your work. Welcome back. 3 out of 10 equals what out of 50? Well, I have to ask myself, what do I multiply to the top and the bottom that turns 10 into 50? Well, I have to multiply 10 times 5 to get me 50. So 3 times 5 is 15. 10 times 5 is 50. So 3 out of 10 equals 15 out of 50. Okay. Oh, a little, no, actually this is not that bad. I thought this was going to be a little bit worse, but it's fine. 6 out of 11 equals what out of 33? Well, I'm going to multiply the top and the bottom by a number. 11 times what gets me 33? 11 times 3 gets me 33, so I'm going to have to multiply the top and the bottom by 3. 6 times 3 is 18. So 6 out of 11 is the same as 18 out of 33. Okay? All right. Hey, we did it. Short and sweet. But that's what you do when you're trying to get equivalent fractions. You're trying to make two fractions that are equal to each other. We did it, and boy, did we have a good time. As usual, thanks for watching. As usual, please like and subscribe and tell your friends and family and classmates all about me. I love you, and have a good day. Also, wrong side. Go them. Bye. The lights went out. Bye. It's spooky math. Bye. If you've never seen any of my videos before, you're probably really confused. Bye. I'm running out of breath. Bye.